So let's move on in TM mode in rectangular waveguide. So TM, right? So if you hear TM for this rectangular waveguide, that means HZ, right? So basically waveguide for the transmit propagate wave to Z direction, right? So propagation is along Z. So HZ, right? HZ, which is perpendicular to the propagation direction, should be 0, right? TM means transverse magnetic means, and then EZ is not here, right? In rectangular waveguide. And then TM is this condition. So likewise, TE. So TE use HZ, right? Use HZ with separation of variable, right? So EZ for TM case, so we just use TEZ field, but we will have same form of HZ in the TM case, right? So we just use the same partial derivative equation so that we will have similar term, but only difference is EZ for this TM case, right? So this is different actually. So from this waveguide, so we know the boundary condition. That means electric field at this boundary, right? This kind of metallic boundary, PEC, or high conductivity material should have no tangential electric field, right? At the boundary. So what does it mean? EZ, right? EZ is this direction, right? EZ is this direction. So EZ is always tangential to this all the surfaces, right? So this is clear. So EZ should be 0 at x is a, and x is 0 and x is a. EZ should be 0 when y is 0 and b. So what does it mean? That means EZ should follow the sine form, sine, something like this. Because to make 0 at the boundary, it should be sine form, or something like this, right? And then along this y-axis, it should be like 0 here, 0, right? Or something like this. So that this term should be gone, right? And then from this condition, kx can be n pi a, ky can be n pi b. This is same as TE case, kx and ky. So that EZ become b times d sine n pi a sine n pi b e to the minus j beta z, right? So beta, so as you know, right, k square n pi divided by a square and n pi divided by b square, and then we just put the square root of it. So this is a wave number for the propagation along the z, right? So what is the difference? Because compared to TE, the difference is sine function, right? For electric EZ. So if one of them is 0, right? M is n, or n is m is 0 or n is 0, which means EZ is 0, right? So it doesn't satisfy this condition, right? So for TM case, TM10, TM01, TM00 mode is not possible because EZ is simply become 0, right? So the lowest mode can be TM11. At least M and N should be 1 to make EZ is not 0, right? So this is the lowest mode. So for this case, right, so TM11 is the dominant mode for TM case, right? So compared to TE case, T case dominant mode is TE10 mode, right? So TM10 mode has a lowest frequency than TM case, right? Right, so this is one thing we need to remember. And then this is same as TE11 mode cutoff frequency, right? If we put the equation for TE case, the cutoff frequency will be same. So that means both mode can be supported at frequency, right? So if I see, yeah, right. So for TE case, right? TE case is possible from here, right? Let's say from here, right? From here to here, TE mode, right? But TM mode is possible from this way, TM. But FC11 for TE, TM mode are same, right? Because the equation is same actually. This is this equation, or kind of apply to TE, TM case. And then for the waveguide, this kind of K-band waveguide, right? K-band waveguide is working for 18 to 27 gigahertz. So for this one, we would like to kind of use this waveguide, this kind of waveguide. So waveguide, we will have something like this structure, this kind of structure with a like a long box shape, and then we want to deliver the signal from here to here, right? From this frequency. Then what we design is we make all the A and B of this waveguide to make this frequency from TE10 mode and TE01 mode to this frequency, right? So this is 18 and 27 gigahertz, right? And then so if we design this A and B and then cover this frequency maybe over here, right? Something like this. Then what does it mean? In this frequency, right? There's two modes, right? And then over more frequency, there's a TE. So for in this region, right? So there's a TE11 mode can be possible. TM11 mode also possible. So TE10 and TE01 is default, right? So as frequency goes up, right, there is a more modes is possible. So that is not efficient, So we would like to have a kind of single mode in the waveguide to efficiently transfer the wave from A to B. So we need to design A and B to make the cutoff frequency 10 and 01 mode is our operating frequency. So please check that, and then the real waveguide structure provide this operating frequency.